Hi, I want to go over a few factor tricks when you're trying to figure out whether a number has certain factors or not. This is always really useful. It comes up over and over and over again in almost all subjects of math. And I think a lot of teachers who are really good at math, that's why they're your math teacher, they take it for granted that you can just have these off the top of your head. But it takes doing some math over the years, and some people I think get intimidated by numbers, so they never quite get really good at it. They're always looking back to make sure something is a factor. So if you keep these tricks in mind, start using them. Um, you'll get really good at them, and they'll become kind of second nature to you. So I'm gonna make a little list of numbers that we kind of we need pretty often. So 2, 3, 4. That's just basically the numbers from 2 to 10. 6, 7, 8, 9. We don't have room for 10. We'll do 10 anyways. So I just wanted to make this list, to show you some of the things you already know. Some of them are kind of obvious. You probably know them. I'll just go through them just in case. If you're in fourth grade watching this, maybe you don't know it. But yeah. So any number, whatever number you want, if its last digit is even, so 0, 2, 3, 4, 5, or sorry, let me start that again. If its last digit is even, 0, 2, 4, 6, 8, those are the even digits, then the number itself is even. And one of the reasons for this, it's always good to have kind of literacy. You might know that fact, but why? How do we know that? Think about how we actually know that. Is that imagine a number like 1,320. Okay? Now, this is a multiple of 10 because it ends in 0. I told you we'd do 10. Let's do 10 right now. Anything that is a multiple of 10 ends in 0. So we know this is a multiple of 10. And 10, so we could rewrite it as 10 times something. It's not too hard to find out that's something, but it doesn't matter, so I'm not going to do it. So we could also write that 10 as, 2 times 5 times something. Right? So 10 is 2 times 5. So it always has a 2 in it. So anything that is a 0 has a 2 in it. Okay, well, if we do 1320, which we've just said is an even number, plus an even number, we always get an even number. Maybe I'll go over how we know that in a different video, but I'm trying to stay focused here. So 1320 plus an even number is another even number. Well, what are even numbers? Well, 2 is an even number, 4 is an even number, 6 is an even number, and 8 is an even number. So, and you can see if you do this math problem, 1320 plus, say, 6, right? It always just 6 plus 0 ends in a 6. There you go. And whatever you get over here is fine. Doesn't really matter. So, again, you probably know that if a number ends in an even number, an even digit, then it's even. But it's good to think about why, because that sort of thinking can help you maybe reason out some other things. So how do you know if something is a multiple of 3? We've already got 2 done. So it turns out that if you add up all the digits of the number and they add up to a multiple of 3, then you have a multiple of 3. So let's try 36, for example, as an example. As a simpler example. You probably know 36 is a multiple of 3. If you know your times tables, it's 12 times 3. But if you don't, let's check how it works. So 3 plus, and I won't write equals. Never write equals unless you mean equals. And I'm going to say this gives you, with our algorithm here, it's a little arrow, 3 plus 6, which does equal 9. 9 is a multiple of 3. Therefore, 36 is a multiple of 3. Suppose we do 72. gives you 7 plus 2 also equals 9, multiple of 3, therefore 72 is a multiple of 3. So one possible issue could come, so 9,900, or let's write some more 9s and 6s, and okay, so 99,996,633. Now I've engineered this to be a multiple of 3, but so we got 9 plus 9 plus 9 plus 9, that's 36, plus 6 plus 6, that's 12 more, that's 48, plus 3, that's 54. So if you add up all the digits, that gives you 54. You're like, oh, great. I don't know if 54 is a multiple of 3 or not. Well, guess what you can do? You can do 5 plus 4. Is 54 a multiple of 3? That's 9, so therefore it is. Okay? Okay, so let's do 4 now. And now 4 is not the easiest one, but there is a pseudo trick for figuring out whether something is a factor of 4. And it's related to kind of the trick for figuring out if something is multiple of 2. So we'll start off with the fact that 100 is 25 times 4. So anything that is a multiple of 100 is also a multiple of 4 because it has a 4 in it. So suppose we start off with a number like 3,600. Okay, we know that's a multiple of 4. Now suppose we go up by 3,616. How do we know if that's a multiple of 4? Well, turns out that whatever these first two leading digits are, 36, 74, 97, we know that if it were 0, 0 as the last two digits, we'd have a multiple of 4. So if we have a multiple of 4 more than the last two digits, say 16, we also know we have a multiple of 4. If you start off with an even multiple of 4 and you add 4s, it's going to be a multiple of 4 again. So the only two digits you have to look at for this for a multiple of 4 is the last two, because you know the number minus those last two digits. If you just had blanks, meaning zeros, that would be a multiple of 4. So with 16, you know 16 is a multiple of 4, good for you. But what if I had 3,676? How do I know if 76 is a multiple of 4? Well, there's not really a trick. You can't just add up the digits and see if those digits are a multiple of 4 or something like that. The trick I personally use is I know 20 is a multiple of 4. 4 times 5. And I can, I know my 20s, 20, 40, 60, 80. So what I do is, if I'm not sure, I always go to the nearest 20, which in this case would be 80. Okay, so I know 3680 is a multiple of 4, or it doesn't matter again with the 36. So I know 80 is a multiple of 4. How different from 80 is 76? Well, it's 4 off, so therefore it is a multiple of 4. So that's how I would go. Again, it's a couple steps of math holding numbers in your head. But again, this is why it's good to just know these tricks, start using them instead of constantly turning to your calculator. And over time, you get better at holding numbers in your head. So now we've taken care of 2, 3, 4. 5 is another one you probably know. I'm not going to go into why, but if the number ends in a 0 or a 5, then it's an M5. M5. So, for example, 45 is a multiple of 5. 3,615 is a multiple of 5. You just have to look at that last digit. If it's a 0 or if it's a 5, it's a multiple of 5. So 6 is actually a kind of a derivative one, much like the number 6 itself, because 6 is 2 times 3. Okay, it is what we call a composite number. It's not prime, it's made of other numbers. So if 6 has a 2 and a 3 in it, then if you have a number that is made of both a 2 and a 3, so suppose you have some number equals 2 times 3 times something else, right? 2 times 3 could be written differently as 6 times something else. Okay, so you know your number is a multiple of 6. So all you have to do if you wanna figure out whether a number is a multiple of 6 is it a multiple of 2 and a multiple of 3? And this would work with any composite number if you think about it. If I want to know, maybe how about 18? If something is a multiple of 18, maybe. Okay, if you want to know if something is a multiple of 18, if you know 18 is 2 times 9, right? Figure out if the number is a multiple of 9, which we haven't done quite yet, but we will in a bit, and a multiple of 2. If it's both, then you know it's a multiple of 18. So you can extend this all the way down the number line if you want, but usually you're not asked to know whether a number is a multiple of 18, so don't worry about that too much. So now we've got 2, 3, 4, 5, 6. Maybe we'll do, actually, let's do an illustration of a 6. So 72. So we look at the last digit in 72. That is 2. So we know it is an M2. Okay. 72, we tested that before with our 3 method. 7 plus 2 equals 9. 9 is a multiple of 3. Therefore, it is a multiple of 3. Okay. So now we know that 72 is also a multiple of 6. All right, so 7, I'm kind of going to skip this one. I've heard there are tricks for 7. I've never really found them to be quite worthwhile. Even though I'm kind of a math purist, there comes a certain point when you have to do enough figuring in your head to just make the trick maybe not worthwhile. So I just pull out my calculator to figure out multiples of 7. Not really a good way. The lower multiples of 7, if you were a football fan back before the 2-point conversions came about, you had a lot of scores that were multiples of 7 in football. But besides that, you just got to learn your times tables. The trick I use if I don't have a calculator handy is kind of like the trick for 4, right? I look at, say 217. Okay, how would I know if that's a multiple of 7 or not? Well, I think about 210, right? I think of 70s actually, in general, and then I go from the 70 to whatever number I have. So that was maybe a little too easy. 210 is a multiple of 70, because you can see it's a multiple of 10 and it's a multiple of 7. Or actually, sorry, how do I know it's a multiple of 7? Well, it's 70 times 3. That's what I know. So it's 7 more than a multiple of 7. Therefore, it is a multiple of 7. Let's do a number that's not as obvious. I'm going to pick out a random number and see if I can do this. 465. I guess it depends if you're good at subtracting. I went right to 490, which would be 7 times 70. But a lot of people find adding a little bit easier. So 420 is 6 times 70 plus 45. If you know your 7's tables, 45 is not a multiple of 7. So not M7. Again, you got to be reasonable if you are in a cave with no calculator or something like that, and you need to know your multiples of 7, whether a number is a multiple of 7 or not. That's something you could do, but otherwise I suggest use a calculator. So I'm not going to claim that I showed you a multiple of 7 trick for this one. Multiples of 8 now. Again, this one's almost not worth it. Personally, I don't really use this one too much. Again, emergencies when you don't have a calculator, you really need it. They're pretty rare. But so similar to 4 or 2, right? 2, we know if the last digit is a 0, then then you have a multiple of 2 there, because it's a multiple of 10. 4, we know if the last 2 digits are 0, so all the multiples of 100, remember, equals 4 times 25. So we know the last 2 digits. So it turns out that to get to a nice ending in 0 number, we have to go all the way to 1,000 equals 125 times 8. So for 8, technically the trick would be, 4,975,000, 424. Okay, for 8, the trick would be you only have to look at the last 3 digits, because you know that 4,975,000 is a multiple of 8 because it's a multiple of 1,000. It has 1,000 in it, therefore it has 8 in it. And then look at 424. Oh, well, of course, I know all my multiples of 8 all the way through 1,000, right? No, I don't. So 424, you just have to use your cleverness to figure out if 424, this is why this is not really a trick. I might break it apart. 400 plus 24, right? 400 is 80 times 5, right? 80 times 5, that is 8 times 10. Okay, so I know that 400 is a multiple of 8, and then 24 is a multiple of 8. So this is a multiple of 8. Again, not really a trick, so we're not going to count it as a trick, but again, it's kind of a way to think about these things. We are going to end with 9, and I say fittingly because 9 was the first trick I ever learned, which was on a great show called Square One TV. I recommend you check out some old YouTube clips of it. They're usually very grainy, but it is the best show ever. Made me love math. I don't know why it still doesn't exist in some form. It's back when PBS maybe had more money or something. Maybe HBO should pick up Square One also. But 9 is a trick very much like 3. And, and I want to caution you, some people learn the trick for 9 and 3 and they assume that it works for all the numbers. It only works for 9 and 3. And I would encourage you, maybe I'll go through why 9 and 3 work in a separate video, but you're just trying to learn the tricks in this one. So we'll just go to it, which is that if you add up all the digits of the number and they come out to a multiple of 9, then you have a multiple of 9. So for example, 721, okay? So 721, 7 plus 2 plus 1 equals, oh no, it's 10. So we know 721 is not a multiple of 9. So let's go to 729. Now 729 is 7 plus 2 plus 9 equals 18. 18 is a multiple of 9, so we know this is a multiple of 9. Yay! So you can do that with any number. So again, similar to the 3 trick. Okay, so hopefully this will be helpful. I hope you learned a lot of cool tricks, and also, again, if you start working with these, if you start using some of the principles behind the tricks, kind of like with 4. You'll be a lot smarter at thinking about how numbers and factors work in general.